Okay, here's the revised masking simulator here. You can see some changes in the layout. I've got the masking quizzes adjacent to the tabular audiogram, to the left for pure tones, to the right for speech. This might look a little different on your tablet. I can't speak to that. I've designed it mainly on a monitor for a laptop or desktop computer. And the other thing you'll notice is that we only have unmasked bone conduction for one ear instead of two, because that's a little bit more realistic in everyday life. And so I think this will be a little bit more helpful for practice. So let's start with the quiz. Using headphones with a minimum intraoral attenuation of 40 dB, do we need to mask for air conduction? So let's eyeball our audiogram here. Is there a 40 dB difference between anything, really, between bone and air or air and air? And the answer is no. I don't see any 40 dB differences for air conduction. So next, bone conduction. Do we have an air bone gap of 15 dB or greater? And we do in some cases. So let's start what we say we do. We click yes and start going down one by one. Looks like the left ear 250 hertz, and then the right ear at 500 hertz, and then not at 1,000, and then not at 2,000. At 4,000, we've got the left ear at 4,000 hertz. And then that's it for bone conduction. Let's double check here. 30 versus 45, yep. 35 versus 45, nope. 15 versus 30, yep. So I think that's right. I was off here, false positive. Right ear at 500 hertz, I do not need to mask. Yes, I should have marked left ear instead of right ear. That was my mistake. There we go. Now we've got that corrected. So let's move on to our SRT masking. So the first thing we want to compare is unmasked SRTs to each other. 40 minus 40 is 0. So based on air conduction versus air conduction SRTs, we don't need to mask there. Now we need to compare unmasked SRTs to best bone conduction in the non-test ear. And we're just focusing in on 500, 1,000, and 2,000 hertz. There are different authors who focus in on different frequencies, maybe including 4,000 hertz. But we're not including 4,000 hertz here because of the prevalence of false air bone gaps, and because SRTs match up better with 5, 1, and 2 anyways. So let's see, 40 versus best bone conduction, which is 15. 40 minus 15 is 25. We don't need to mask for the right ear SRT or for the left ear SRT. So we say no there. Now WordRec's a different story. WordRec's always at a higher level. 70 dB for WordRec versus 15. Using headphones, we do need to mask there because 70 minus 15 gives us 55. How about 60 minus 15? Well, if 60 minus 15, that gives us 45. So we need to mask for both ears for WordRec here. Let's submit our answers. We've passed our clinical quiz for both ears. So now let's move on to next step is going to be WordRec masking, because we don't have any air conduction pure tone masking to do. We don't have any SRT masking to do. We just have bone conduction masking and WordRec masking. So we'll start with WordRec masking. Moving to WordRec here, headphones, right ear. We have our presentation level given to us at 70 dB, and we can cheat a little bit if we want to and look over here to the right side for our initial masking level. But let's break it down. Let's calculate it out here. There's a few ways we can think about this, but let's do it the way that we are supposed to. So presentation level is minus intraoral attenuation level. So 70 minus 40 is 30. And then we have the largest air bone gap in the non-test ear. So we're in the right ear. What is our largest air bone gap in the non-test ear? In the left ear, it appears to be 15 minus 30 minus 15 is 15. So we're going to start at that masking level at 45. That gives us a little bit plus our So I figured out the discrepancy here. We need to add our safety factor of 5 dB, and that gives us, that helps us match up here with our initial masking level here. I think it's just our formula here, our speech masking formula. It doesn't have our safety factor built in here, but if we go down to our clinical reference guide at the bottom, it does have our safety factor built in there. So I'll have to add that minor little hang up. So we have the appropriate word list, and then we've got a response here. 70% is our response. Let's go ahead and test for the left ear now. Going to the left ear, and we're going to also present at 60 dB here. So 60 dB is our presentation level here. 60 dB minus 40 gives us 20. And then we have our largest air bone gap in the non-test ear. So the right ear air bone gap, right ear air bone gap, I see a 10 dB air bone gap is our largest that I can see. So we're going to add 10 dB on top of that, plus a safety factor. That matches up here, 35 dB. So we're going to present our word list here. And so let's just do our little cheat sheet here and see how PB Max matches up. PB Max is 70% here, and our initial masking levels are both matching up fine. So the only error I'm seeing is just our formula here is missing out on our 5 dB safety factor, but it's present down on our clinical reference guide. So very minor thing there. We've got our masked word recognition thresholds here, all set to go. Those are saved. And now for the next part here, we want to go ahead and mask for our bone conduction thresholds. We need to mask for left ear bone conduction at 250, 500, and 4,000. So let's move on to tone. And our bone conduction oscillator, 250, start at 250 here. And for our unmasked threshold, that's at 0. And then our non-test ear is the right ear at 10. So we're going to add 10 to that to make 20. But we got to add our occlusion effect for bone conduction testing. Occlusion effect for headphones is 15. And we are using headphones. We can go up here. I guess it disappeared, but headphones are what we're using. Or actually, it shows it right here. Headphones, right there. Yeah, so 15 dB for our initial masking level, presenting the tone. We get a response. Let's go ahead and raise the masker level. We got a response. Got a response. Got a response. We plateaued. Save our mask threshold there. Boom, mask threshold saved. So now we need to move on to 500 hertz. Okay, initially our unmasked bone conduction threshold is 15 dB. So we'll put it at 15 dB. On non-test ear is the right ear. It was at 25 dB. So starting at 25 dB, plus our occlusion effect we've got is 15 dB as well, bringing us up to 40 dB. And we can see our cheat sheet here. Cheat sheet's a little bit off here. Let me double check that here. So let me double check this here. So again, 500 hertz in the left ear. Our unmasked threshold is 15. For the bone conduction, our non-test ear threshold is 25. So we're going to add 10 to make 35. Oh, and occlusion effect is 15. So we have to add another 10. So let's start there, presenting the tone. We get a response, get a response, get a response, get a response. We plateaued, we save that. And then that one is saved there. Let's make sure it's saved. Yep. And now we need a mask at 4,000 hertz for bone. So left ear again, we're going to start at 30 dB. we go. And then for the right ear, unmasked threshold is 35 dB. There's no occlusion effect. We're just going to go 10 above, which is 45 dB. We're going to present the tone, no response. Bring up the tone, no response. Bring up the tone, got a response. Bring up the masker, bring up the masker, bring up the masker. We plateaued, saved our mask threshold, and we have completed all of our masking that we need. We've completed masking for word recognition. We've completed our bone conduction masking that we need. We can see that we've got a conductive component in the low frequencies for the left ear, but that's predominantly it for the conductive component. Everything else appears to be sensory neural. So that's the first example here. I'm going to go fix a glitch or two before our next example. Okay, I should have the quirks ironed out now. So here's our next patient with using headphones with minimum intraoral attenuation of 40 dB. We need to see if we need to do air conduction masking on this here. So we can take a look at the audiogram. At 250 hertz, it doesn't appear we need air conduction masking. At 500 hertz, it appears we might. Let's take a closer look. 35 minus 0, so we do not need air conduction masking for 500 hertz. 1,000 hertz we don't. How about 2,000 hertz? 50 versus 10 is 40, so we do need air conduction masking at 2,000 hertz for both ears. So we'll mark that, 2,000 hertz for both ears. And let's go look at 4,000 hertz. Let's look at 45 minus 10 is only 35, so we don't for 4,000 hertz, and then we do not for 8,000 hertz. So we require some air conduction masking. Now let's take a look at bone conduction masking. 250 hertz we're good. We need it at both ears at 500 hertz, so we'll mark it for 500 hertz at both ears. And then 1,000 hertz, we need it for both ears at 1,000 hertz as well, just barely, but we do need it for both ears at 1,000 hertz. 2,000 hertz, we need it for both ears as well, very obviously. And 4,000 hertz, very obviously, we need it in both ears as well. So we'll submit our answers, and it didn't give us any errors, so we know that we responded correctly. And now we're going to go ahead and move on to SRTs. So SRTs, let's go back to the top here, SRTs. We've got 45 minus 35 is a 10 dB difference. Based on our air conduction versus air conduction SRT rule, we don't need to do masking based on that, but we have to compare it to best bone conduction now. So SRT 45 versus best bone conduction of 0, that's a 45 dB difference with a transducer that has an intraoral attenuation of 40. So we got a mask for the right ear SRT. How about the left ear SRT? 35 minus 0, we don't need a mask for the left ear SRT. How about word rec? You can pretty much guarantee if you have to mask for SRT in an ear, you have to mask for word rec. And so that's the case here. So right ear, 85 dB minus 0 dB. Clearly we got a mask for word rec in the right ear. In the left ear, 75 minus 0. We get a mask for word rec in the left ear too. So we'll submit those answers, and those are correct. We passed both those quizzes, and now we move on to getting our air conduction thresholds that we need for 2,000 hertz. So if we go down to our little cheat sheet area here at the bottom, masking required for air conduction at 2,000, it's kind of buried away in here, but air conduction at 2,000 hertz. Let me take a closer look. Right ear air conduction, left ear air conduction, that's all we need. We can also just eyeball the audiogram here and see that that's where the kind of the lightly shaded audiometric symbols are. So 2,000 hertz air conduction, we'll start with the right ear because why not? And 2,000 hertz in the right ear, and our air conduction threshold was at 50 before, so we'll raise it up to 50 here. And our non-test ear was at 50, so we'll put 10 more for 60. And there is no occlusion effect at at 2000 hertz, so we're good to start masking here. So we present our tone. Yes, we get a response. Let's raise it up 10 dB, get a response. Another 10 dB, no response. Let me drop it down. There we go, we plateaued. That was the short, so I raised it 10, we got a response. I raised it 10, I got no response. I dropped it 5, we got a response. We had a very narrow plateau there. So I was unwise by using 10 dB increments. I should have been using 5 dB increments, but we'll save our mask threshold there, and I'll be more cautious for this next year. So we need to mask for the left ear now at 2000 hertz. So 2000 hertz, 50 dB also is where we start at in that left ear. It's just high, it's very faint. It's right behind the 50 dB masked right ear conduction threshold. It's hard to see, but it's at 50 dB there. And then we need to start our masker at 10 dB above the masked air conduction threshold in the opposite ear. So we present our tone, get a response, present our tone, keep raising the noise, getting a response, and then we got a plateau there, saving that threshold as well. And now we have our masked air conduction thresholds. Now that we've got our masked air conduction thresholds, let's move on to our SRT. So our SRT in the right ear was 45 dB. So let's set that SRT up for right ear at 45 dB. Now, if we remember, we need to present, if we remember our little rule here, we need to present, for our rule is test ear minus, test ear level, 45 dB minus intraoral attenuation, which is 40. That gives us 5. So we're going to start there at 5, plus largest non-air bone gap in the non-test ear. So we're looking in the left ear for the largest air bone gap in the non-test ear. And that would appear to be, from what I can tell, we've got a couple candidates here, 50 versus 10, that's 40 dB, or we've got 35 versus 0, that's 35. So it looks like we need to add 10 versus 50, which is 40 dB, 40 dB onto that for our largest air bone gap. And then ordinarily we would add the occlusion effect, but I think we can be pretty confident that, I guess we could be safe and add the occlusion effect. I was going to say, if you have a conductive loss, you don't add the occlusion effect, but we're at, we don't have to worry about the occlusion effect anyways, because we just have to add a 5 dB safety factor. There we go. So let's present our spondee, and we got a response. Let's go up 5 dB, got a response, 5 dB, got a response, 5 dB, got a response, and we plateaued, saved our mask threshold there. And there we go, 45 dB mask threshold for SRT. Now we're going to go to the left ear, and we're going to start at left ear. We're starting at 35 dB, because that was our unmasked threshold in the left ear. And for our masker level, we need to start at presentation level, 35, minus intraoral attenuation, which is 40. Do we need a mask in that ear? I'm sorry, we don't need a mask for SRT. We didn't need a mask for SRT. We need a mask for word rack. I'll double check down here. SRT, yeah, it was just the right ear. We don't need a mask for left ear SRT. We need a mask for word rack now. So let's move on to word rack for the right ear. So word rack for the right ear here. We have our presentation level at 85 dB. So let's move up to 85 dB for our word rack. And then we minus our intraoral attenuation of 40. So we're starting at 45 dB plus our largest non-test ear air bone gap. And that largest non-test ear bone gap is, like we already said before, a 40 dB air-bone gap to add on there. So it's 85. We might get into overmasking, 5 dB safety factor. We might be getting into overmasking territory here. Let's take a look. Let's see what we got here. And let's see what our cheat sheet shows us here. Oh, we got it right. We got it right. 85 and 90. And we got max of 80% correct. We got that 100% right. Just so happened we weren't overmasking. We could have been overmasking in this situation, but we weren't happened to be overmasking in this situation. But let's check for the left ear now. For the left ear, we're going to present speech at 75 dB, so that's a little bit lower chance of overmasking. Because 75 dB minus 40, we start at 35, plus our largest air-bone gap. Largest air-bone gap is 40 dB, so we're going to add 40 dB to that, equals 75, plus a 5 dB safety factor, present our word list, and let's see here. We'll check our cheat sheet here, and 75 and 80, that's correct, and max word rec 75, so we are exactly right for word rec on that one too. So yeah, we are good on that one as well. So we're good for word rec, and we are good for SRTs. We just need to move on to mass bone conduction thresholds. So let's move on to mass bone conduction thresholds here. So it looks like we need to mask for bone conduction at a variety of frequencies here. We're good at 250, but at 500, we need to do some masking here. So 500, bone oscillator. We're going to start the right ear, which is 25 D, which is 0 dB. And then in our non-test ear, which is 35, we're going to add 10 dB to that, which is 45. Because we're doing bone conduction masking, we have to add the occlusion effect. Because we have headphones here, yeah, we have headphones, I'll double check headphones. We have to use the headphone occlusion effect, which is 15 dB right there. So we add another 15 dB on there. And now we can present the tone. We got yes, and we're going to go ahead and raise the masker, present the tone. We got a no, raise the tone, got a yes, raise the masker, got a no, raise the tone, got a yes. Looks like the masking profile is linear, and I think we're going to not be able to complete, save could not test here because it's a little bit too large. We can try one more thing here. We can try to get rid of the occlusion effect, which is 15 dB, and start over to see if that works. Because it could be a conductive loss. We don't know if it's conductive or sensory neural, but we can try to get rid of the occlusion effect. So we're going to start over here without the occlusion effect at 500 hertz, 45 dB plus 5 for a safety factor of 50. We're going to clear our history here, present our tone, got yes, present our tone, yes, present our tone, yes, present our tone, no. Oh, we didn't get a plateau. Let's bring it up there, yes, no, yes, no. Okay, yeah, safe could not test. So we have could not test on that one because we have overmasking on that situation for the right ear. Yeah, we've got clear overmasking. So let's go to the That was the left ear. I thought I was testing the right ear. Let me switch over to the right ear. Let's check that again. Right ear would have, we're going to do it without the occlusion effect to be safe here, 45 dB for the right ear. And starting out at 0 dB. Present tone. Raise the masker, yes. Raise the masker, yes. Raise the masker, yes. We plateaued. Okay, we've got a right mass bone conduction threshold. Let me go back to the left one again, because I might have had that mixed up. So let's go back to the left ear starting at 0. I thought I had it on the right ear, but maybe I didn't. So with the left bone conduction threshold here, the right ear we would start at 35. Ordinarily we would add the occlusion effect, but we're not going to do it right now. 35 plus 5 for a safety factor. Present the tone, yes. Present the tone. Present the tone. Present the tone. We got a mass threshold there, so we're good. The reason we didn't need the occlusion effect there is because we already had an air-bone gap. And if you have air-bone gaps, you don't need the occlusion effect. But you don't know that unless you've got maybe a tympanogram to tell you that you have a probable air-bone gap. You're just trying it after the fact is what it comes down to. So we got our mass bone conduction thresholds safely there. And now let's go ahead and check 500 hertz. We need to mask for... Looks like it changed on me automatically here after I saved it. So in any case, we're going to do 500 hertz in the right ear. We just did 500 hertz in the right ear. I'm sorry, we're going to do 1,000 hertz in the right ear. Yeah, it didn't change on me. That was me. 1,000 hertz starting at 25 dB. And then our non-test ear is at 40. We're going to start at 50 plus a safety factor, 55. And ordinarily we would add we'd ordinarily add the occlusion effect. Because we already see that we have an air-bone gap at 500 hertz, I'm going to assume that we might have an air-bone gap here, so we're not going to add the occlusion effect in to be safe. So we're going to present the tone. We've got a response. We're going to raise the masker, presenting the tone, getting a response. Same thing. We plateaued. Save mass threshold. Same thing we're going to do on the left ear now. Starting out at 25 dB. And the masker is going to be 10 above. So we're going to start at 50. Plus a 5 dB safety factor, which is optional, I would say. And the occlusion effect is also going to be optional here. We're going to present the tone here. Got no response. Let's go up on the tone. Got a response. Let's go up on the masker. Got a response. Masker. Response. Masker. Plateau. Save it. So it looks like sensory neural there. Now 2,000 hertz. Very likely going to be an air-bone gap in at least one of the ears. So let's go ahead and see what's going on at 2,000 hertz here. We'll start with the right ear. Starting our threshold at 10 dB. And then we're going to start our masker at 10 above 50, which is 60, plus a 5 dB safety factor. We're going to present the tone, got a response, bring up the noise, response, bring up the noise, response, bring up the noise, response. Oh, no response there. Almost a plateau, but not quite. I wonder without the safety factor if it would be a response. Let's get rid of the safety factor for a moment, back to 60. We'll plateau without the safety factor. So with our masking profile, let's see what happens when we go down lower, 55, just out of curiosity. at 50. Yeah, we're already in the plateau. So yeah, I think we're okay saving that as a response, getting rid of that safety factor. Maybe getting rid of that safety factor is the safe way to go with bilateral conductive hearing loss. So we had our masker up to as high as 75, so that's what we save it as. And now we're going to move to the left ear, starting at 10 dB, starting at 10 dB above the air conduction threshold. This time we're not going to add the safety factor, we're not going to add the occlusion effect, because we know there's a high risk of crossover. So we're going to present the tone here, no response, up on the tone, no response, up on the tone, response, up on the masker, response, up on the masker, response, up on the masker, response, we plateaued, we saved. So we're good there. Now we got to go to 4,000 hertz. Hertz. We're starting in the right ear at 10 dB. And in the non-test ear, we have 45 dB, and we're going to start at 55 dB. And there is no occlusion effect here, and we're not even going to add the safety factor in there. We're going to ignore the safety factor, and we're going to present the tone here. No response, go up on the tone, response, go up on the noise, response, go up on the noise, response, go up on the noise, response. We've reached plateau there. Now we're going to go to the left ear, starting at 10 dB. For the noise, we're going to start 10 above the right ear, so 50. Present the tone, response, masker up, response, masker up, response, masker up, response. Now we've got our audiogram. We've saved our audiogram here. We've got left and right masked bone conduction thresholds for all test frequencies except 250 because we didn't have a greater than 10 dB air bone gap. So we've got a good audiogram here. Okay, here we've got another audiogram, this time with supraoral headphones of a minimum intraoral attenuation of 40 dB. Here's our audiogram down here. So let's take a look to see where masking is needed. First, do we need air conduction masking? Let's look at the largest air bone gap there is. Bone conduction at 25 dB versus air conduction at 55 dB. That's a 30 dB difference. That does not equal or exceed 40 dB. So no, we do not need air conduction masking. Next, do we need bone conduction masking? Looks like for the left ear we don't. For the right ear we do. At least for 250 hertz. So 250 hertz, we need bone conduction masking in the right ear. 500 hertz, we're good on both. 1,000 hertz, 2,000 hertz, 4,000 hertz, we're good on both. So just 250 in the right ear. We'll submit the answers. We didn't get any error messages, so that's correct. Now we'll take a look at our SRTs that we need. Do we need SRT masking? 40 versus 35, no big difference there. Now we look at SRT versus best bone conduction at 5, 1, or 2. 35 versus 25, that's a 10 dB difference. Nope, we don't need it. 40 versus 25, that's a 15 dB difference. Nope, we don't need SRT masking. How about word rec masking? 75 versus 25. Yep, we do need it. And then 80 versus 25, we sure do need it. So both ears, we need word rec masking. We submit the answers. We get it correct in both ears. And so now we need to move on to our speech masking because we only needed to do bone conduction masking down looking at the bottom here, bone conduction masking at 250 and word recognition masking. So let's start with word recognition masking. For word recognition masking, you can see I got the safety factor back in. It was missing before, but we've got the little formula corrected there. So we're going to start with word recognition at 75 dB in the right ear. And we'll present it at 75 dB in the right ear here. And we look at the minus interoral attenuation level of 40. That gives us 35, plus our largest air bone gap in the left ear, because that's our non-test ear, appears to be 10 dB is the largest air bone gap in the non-test ear. So we'll add 10 dB and 5 dB safety factor. We'll present our word list, and that's what we got there. And then we're going to go ahead and move on to the other ear, to the left ear. And left ear presenting at 80 dB. 80 dB minus 40 dB is 40 dB, plus largest air bone gap in the right ear now. Largest air bone gap in the right ear at 5, 1, or 2 appears to be 0, honestly. It appears to be 5. At 500 hertz, we have a 5 dB air bone gap, plus 5 dB for safety factor. So we'll present our word list there, and that's what we get there. And let's go ahead and look at our cheat sheet and see if it matches up. It sure does. Our PB max matches up, and our noise levels, let's see if our noise levels match up. Oh, for some reason, my word rec doesn't match up on the left ear. It seems to be a little glitch. Our PB max matches up, and but our word rec has a bit of a glitch going on there. But that's okay, because we did it appropriately according to the right formula. That's just a glitch in the software. So let's go ahead and mask for 250 hertz in the right bone conduction now. So bone conduction, right ear at 250. And we're going to start at 250 in the right ear at 25 dB. In the non-test ear, we've got it at 40 dB. And ordinarily, we would add an occlusion effect here. We can give it a shot at 15 dB occlusion effect. We can give it a try and just see how it turns out. And we'll go ahead and present the tone. No. Let's bring the tone up. No. 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 So what's going on here? Nope. We can still go up higher. Tone up. Yes. Masker up. Yes. Masker up. Yes. Masker up. Yes. We plateaued. Saved our mass threshold there. And so we've got our masked bone conduction threshold for, looks kind of, oh, I see the problem there. I didn't switch it from headphones over to headphones. That was my mistake. I should have switched that over to the bone oscillator. So we'll do that again here. So I masked it out at the exact same frequency. That was my error. So we'll try that again here. We'll just clear out our history like we did. We go back down to 25 dB for bone. Notice that we got the exact same air conduction unmasked and masked. They came out to be the same. Even though I made an error there, it didn't have any effect. Now, going to 40 dB for the masker, plus 15 dB for the occlusion effect. Present the tone. No. Let's go up on the tone. 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 Now we go up on the masker. Go up on the masker. Go up on the masker. We got a plateau. Save our mass threshold there. That's all we needed to do on that one there. So we are good on that audiogram. Okay, here's a final case study for the recording, and I'm happy to do more recordings if this is beneficial for you all. This time we use insert earphones which have a minimum intraoral attenuation of 55 dB. If we take a look at this audiogram here, we can see if we need to do air conduction masking. We see some large air bone gaps here. Let's take a look at some of the largest. We see 85 dB versus 35 dB. So 85 minus 35 is 50. Not large enough to require air conduction masking. But let's look at 8,000 hertz. 90 minus 40 is 50 dB. Again, not large enough to require air conduction masking for inserts. If we had headphones, that would be a different story. But because we have inserts here, we don't need to do air conduction masking in this situation. So we'll say no to air conduction masking. Oh, but certainly we have to do bone conduction masking. So let's just mark this yes right off the bat. Let's take a look at what frequencies we need to do bone conduction masking for. We can see 250 hertz in the right ear because we have a greater than a 15 dB, we have a greater than a 10 dB air bone gap. We can see that we need to do 500 hertz in the right ear. We can see that we need to do both ears at 2,000 hertz. I'm sorry, let's start at 1,000 hertz. Left ear at 1,000 hertz, and not the right ear at 1,000 hertz. And then both ears at 2,000 hertz. And then 4,000 hertz. We also need to do both ears at 4,000 hertz here. So quite a few for that. Let's see if these are the right answers. Oh, yep, we didn't get any error messages, so we got all the right answers there. Now we need to see if we need to do SRT masking. So SRT, we're comparing 60 in the right ear versus 70 in the left ear. There's no difference greater than 10 dB air conduction wise, but we need to compare it to bone conduction. So compared to best bone conduction, 60 versus 30 dB difference. That's less than 55. We don't need a mask for SRT in the right ear. 70 versus 30. That's only a 40 dB difference. No for SRT masking. How about word rec masking? It's 75 and 85 dB HL. So 75 dB HL, comparing that to 30 dB HL, it's a 45 dB difference. Nope, we don't need to do it there. How about 85 versus 30? Well, now we have a 55 dB difference. So we do have to mask for the left ear. So left ear only. Let's see if we got that right. Yep, we passed that clinical quiz. So now let's see what masking we need to do here at the bottom. We need to do a bunch of bone conduction masking, no air conduction masking, except left ear for word rec. So let's do left ear for word rec right off the bat and get that out of the way. So left ear word rec here with inserts. We're going to start off at 85 dB is our presentation level. So we'll bump it up to 85 dB. And our rule is minus intraoral attenuation, so minus 55. That puts us at 30, okay? Plus the largest air bone gap in the non-test ear. So the non-test ear is the right ear. What's the largest air bone gap in the non-test ear for the right ear? It appears to be at 2,000 hertz, 30 versus 55, so that's a 25 dB difference. 30 versus 55 is a 25 dB difference. We're going to add that on top here to make this 55. And then we have a 5 dB safety factor. Let's see how well this works out. We're going to go ahead and present the word list, and let's see what this score turns out to be. We're going to look at our cheat sheet here. First, we'll see if this matches up. Initial masking level of 60 dB matches up with what we had. So I'm getting my bugs and errors corrected apparently. And let's see what our PB max is. PB max was 60% and our score was 57%. So that's right. 85 dB with 60 dB of masking. We got that right. We're going to save our mask threshold there for word rec and saved it right up there. Got that part fixed. So now let's move on to bone conduction testing. Gotta make that oscillator. I always forget about that. Switch over to that oscillator, bone oscillator. So now, it doesn't matter if we start in the right ear or the left ear. We got quite a few to do. Let's just start in the right ear first. And just as a reminder, we can get rid of our cheat sheet here. Right ear, 250. So let's do 250 in the right ear. So 250, we're starting at 45 dB. And then masking in the non-test ear is 10 above, 45, so 55. And we could add the occlusion effect if we want to. If we do add the occlusion effect, that's going to be 10 dB for inserts. So we'll add 10 dB on there, and we'll present a tone. No response. Let's bring the tone up higher. No response. Yes, we got a response. We'll bring the masker up. Yes. Masker up. Yes. Masker up. Plateaued. Safe mask threshold. Boom, we're off to the races. So now let's move on to 500 hertz. So 500 hertz here, we have to start at 45 dB. And our non-test ear, being the left ear, is 55 dB air conduction threshold, meaning we start at 65 dB. Because it's 500 hertz, we need to add occlusion effect. So occlusion effect is 10 dB. We'll add 10 there. And then we could add a 5 dB safety factor if we'd like. And so we'll present the tone, we get a response. Let's make the masker higher, get a response. Masker higher, get a response. Masker higher, we got a plateau. So we're going to save our mask threshold. See how much easier inserts can be. And we don't have to mask at 1,000 hertz in the right ear, but we do have to mask at 2,000 hertz in the right ear. So at 2,000 hertz, we're going to start at 30 dB. And then our noise is going to be 10 above, so 75 in the non-test ear plus 10 is 85. And we have no occlusion effect to add because we're at 1,000 hertz, 2,000 hertz rather. So there's no occlusion effect to add. Let's present a tone. We get a response. Let's raise the masker. We get a response. Raise the masker again. Get a response. We're getting into uncomfortable territory, but we got a plateau. Save our mask threshold there. Now let's move on to 4,000 hertz. And 4,000 hertz unmasked bone was at 35 dB. So we go there, and our masker, we need to start at 95 dB. So that's going to be a problem here. 95 dB on that masker. Let's start it out and present a tone. Got a response. Present a tone. Got a response. We're getting up into territory where we probably don't want to go much higher than 105. So even though we're just at 105, we're going to save the mask threshold even though we have a small plateau of 10 dB. It's probably the right answer, but we can't go up any safer to a higher level. 110 is unsafe. So let's go ahead and check our cheat sheet to see what the cheat sheet says. Cheat sheet says for bone that we've got 55, 45. Let's check those. The first two, bone 55, 45. And then for 30, yeah. And then 4,000, we had 35. Is that what we had over here? 4,000, we had 35. So we got all our bone conduction thresholds right so far for the right ear. Now let's check our left ear. Let's go to left ear here. We'll start at 250. Well, we don't have to do 250 necessarily because we don't have an air bone gap. So we can see down here that 250. We don't need to do left ear. Left ear, we just need to do 1,000, and 2,000, and 4,000. That's what we need to do for left ear. So 1,000, 2,000, and 4,000. So 1,000, we don't have an occlusion effect at 1,000 for inserts. So for 1,000, we're going to start with our unmasked bone conduction threshold at 1,000, which is 45 dB. And then our right ear is our test ear. So we're going to start 10 above, which is 65. We're going to present a tone, no response, go up on the tone, no response, go up on the tone, no response, continuing to go up on the tone. Finally got a response. Let's go up on the masker, again on the masker, again on the masker. We plateaued. Save our mask threshold there. So we're doing good. And let's go to 2,000 hertz now. So for 2,000 hertz, we're going to start with our unmasked threshold, which was, we can look over here, 2,000 hertz, our unmasked threshold. For bone was 75, which is the, unmasked threshold was, hold on. That's air conduction. Bone conduction, masked is 30, which I believe is the same as our unmasked, so we start at 30 there. So starting at 30 in the left ear, and the right ear is where we put the masker at. The right ear air conduction threshold is 55. We do 10 above. There's no occlusion effect. Let's present the tone. No response. No response. No response. No response. Let's see if we get a response at some point here. Not getting a response. What's going on here? Let's see. Oh, we still have a ways to go for our left ear. We could get a response. Now we got a response. Now we're going to plateau. One more. Got our save mask threshold there. Good deal. So that looks like sensory neural in the left ear so far. Now we need to do 4,000 in that left ear. So 4,000, our unmasked bone conduction was at 35. In our masker, we need to start at 65 because 10 above air conduction threshold, no occlusion effect. Present the tone, no response, no response, no response, no response, no response, no response, no response. Got a response there. Let's try to plateau, no response. Got a response. Let's try to plateau. No response. Got a response. No response. I think we're starting to have an overmasking dilemma. We can keep going higher. Let's see what our thresholds are at. 80 dB for 4,000 hertz. We could go a little bit higher and see. Okay, we got a response. Let's see if we can plateau. Yes. It's all because of these inserts. That's what we're plateauing from. Save mask threshold. That was a close one. We got our mask threshold there. And let's check our answers to make sure we got them right. Look at our cheat sheet here. Bone conduction, left ear, 45, 50, 65. 45, we didn't mask there. We didn't need to mask there. Left ear bone conduction, if we had mask, would be 50, but we didn't need to mask there. So we'll skip over that one. And left ear, 65, 70, and 65, 70, and 85 from 1 to 4. 65 is 1 to 4. We got 65, 70, 85. We got the right answers for mass bone conduction. So that is good. We're good on this patient. I think most of the glitches I got squared away throughout this process. Um, I would certainly say the pure tone masking works better than the speech masking, but they both should be working reasonably well now into practice. Please email me any glitches that you have, and I'll fix them. But I'll go ahead and stop this recording here.